The Apache Spark system is super fast. Not only is it a concurrent system, it is using two techniques to make it super fast. So it is a concurrent system, but it is using one, the sequential technique to make it super fast, and two, the zero copy technique to make it super fast. What do you mean by the sequential technique? So when we transfer data from one place to another, we need to read it and then we need to write it to another place. On disks, if we read data in a random matter, then on mechanical disks, it's going to take time to the seek. However, if we read the data sequentially from disks, then it would be 10 times faster. Therefore, Apache Spark utilizes this technique of reading sequentially and writing sequentially to disks. But you may ask now, why do we even refer to standard hard drives where we have an HDD hard drive, standard hard drive SIC? Don't we have already SSDs? So while this is correct, SSDs are faster indeed, and we do not require really a SIC there. It's not a mechanical thing. However, they also cost more. So if you have a large clusters with many disks, you can gain and basically win on both sides. You can also be fast and you can also use older HDDs. So if you have a super large cluster, then this may result in both being fast and also utilizing the lower cost hard drives instead of SSDs. So this was the sequential pattern. What is the zero copy pattern? And as a context, we are describing why Apache Spark is super fast. So the zero copy means that when we read data from disk and we need to send it to another computer, then we read it from disk and basically the process is like this. We read it from the disk, then it's being written to the OS cache, then Kafka gets this data that was originally residing on the disk and then was moved to the OS cache, then it's going to Kafka, then Kafka sends it to the socket buffer, and then from the socket buffer to the network, and only then it reaches the consumer. As we see, we already had many components participating in this sending of the data. So can we do better? And the answer is yes. Just like we use the sequential method in order to read and write data sequentially and gain things to be much faster, we can also use the zero copy technique in order to get a much faster data transfer from disk to cache to Kafka to socket buffers to network and to the consumer, basically to remove many of these parts. So it's going like this, the zero copy. The data still needs to be read from the disk. We have nothing to do about this. The data is on the disk and it's being uploaded into the OS cache. But now Kafka calls the system call send file, and this system call will use a direct memory access and directly move it to the network buffer to reach the consumer. Okay, so this was the second technique. The first technique was the sequential pattern, where we load data from disk sequentially, and in this way we can use cheaper disks which could have 100 bytes per second, megabytes per second, 100 megabytes per second instead of 100 kilobytes per second if we did a random seek. So it's basically on an order of magnitude faster, and we can use the cheaper disk. And the second technique is the zero copy, where in the zero copy, we just use system call in order to directly send the file to the network buffer using the DMA component of the computer, the direct memory access, in order to transfer it fast. So basically what we see here is that Apache Kafka tries to put its hands on whatever it can in order to make things faster. So when we check why is Apache Kafka so fast, because It looked at the problem and said, okay, I need to send things from here to there. Let's look what are all the possibilities for us to be as fast as possible as we can. And then it has a checklist, and it has people that work for it and people on the open source, and then they check number 1, sequential disk access, checked. 2, zero copy, checked. And this is why it's fast.